Given an array of n integers, construct a product array of the same size such that the ith element of the product array is equal to the product of all the elements of the original array except for the ith element. All right, Daisy, thank you so much for being here. Can you quickly introduce yourself for our viewers?
Sure. Thanks for having me here. Hi, my name is Daisy. Um, I am currently working as a software engineer at Uber. I have in total like 5 years of experience. Previously, I worked at Google and Twitter as well. At Uber, I work as a backend developer, wherein I work as part of a team called like Pino, which basically like we manage uh, a database which handles like all the massive data within Uber. Uh, yeah, so that's pretty much like what I do.
Gotcha. Okay, that's a really cool experience. Excited to see how you tackle this problem today. So let's get right into it. Our question today is, given an array of n integers, construct a product array of the same size such that the ith element of the product array is equal to the product of all the elements of the original array except for the ith element.
Okay. So I have to compute the product of all the elements of an array, except the current element. Okay. So let me take an example to clarify the question first. So yeah, just to make sure I understand the problem correctly. So let's say if this is my array, and so my output array should be something like 4 into 5 into 6, which is 120, 2 into 5 into 6, which is 60, and 2 into 48, and 40. Yeah, so is this correct understanding of the problem statement?
Yes, looks correct to me.
Okay, cool. Yeah, so I think how I would approach this is basically I can just compute the product of the entire array. So let's say like for this array, the entire product would be like 240. So I iterate over the array, compute the product of the entire array, and then
Mhm.
I can like to create my output array, I can iterate over the array again, and then I can just divide that by the current integer. Does that sound good?
Yeah, I think that sounds correct to me. Can you tell me what the space and time complexity of that would be?
The space complexity would be big O of 1 if we consider the space complexity of the output array. Uh, no, yeah, if we don't consider the space complexity of the output array, the space complexity would be O of 1, and time complexity would be O of n because we're iterating through all the elements at exactly once.
Okay. Yeah, and you're saying the space complexity is O of one because you're only storing like the product, right?
Yes.
Okay, perfect. Do you want to get started implementing it then?
Yeah, sure. Yeah, let me just create a method first. And
Okay, and can you tell me a little bit about the code that you're writing as you're writing it?
Yeah, sure. So here, I've initialized an integer prod, which would like compute the product of the array. So yeah, I've
Hmm.
initialized it as one. So because basically, like, yeah, product of any number with one is the same. So which is why, like, I've initialized it one, uh, and I iterate through all the elements of the array and I compute the product of the array. Now I have created my output array, and I'm going to traverse through this array, through the input array, and compute my answer. So basically, for this output array, let me also initialize it to the size of the array. So yeah, let me initialize a variable for that. N is equal to,
Okay, great.
yeah. So I've initialized an output array of size n, and initialize it with 0, and now I'm going to overwrite the value with the answer, which would be the product divided by the integer at the current position. So, and finally I return the output array. And yeah, also one consideration is, yeah, I think, like, even if the numbers are negative or positive, I think this should work. uh, yeah, one consideration
Are
is,
there,
let's say, yeah, one edge case I can think of is, let's say the product is negative, which is -1. No, let's say the product is negative, which is like minus int max, minus int min, which would be like -2 per 8. And so the range of integer, like for C++, is -2 per 8 pl- to 2 per 8 minus 1.
mhm.
So let's say if I divide that by -1, in that case that would exceed the range of integer. So I think that is
Right,
one thing
okay,
that I need to handle properly. So yeah, I can, for that I can just use like long instead of integer, just for that
okay.
specific edge case. Uh, Another edge case would be
And
like, if there is a number which is zero, that
yes,
could be another
mhm.
edge case.
How do you
But
think you
let
would
me,
handle that?
yeah, yeah, just let me yeah, do this first. Um,
Hmm.
yeah, now return output. Okay, let me change this to, yeah. Now let me think of what happens if, like, um, there can be a number which is zero. Yeah, so in that case, I can just say that. I mean, in that case, prod would itself would be zero, and for all the numbers. Yeah, no, just to clarify, I think I forgot to ask this question at the beginning. Like, can I assume, like, since you mentioned that these are integers, so I can assume that this can be like any integer, right? Positive, negative, zero.
Yes. Hmm.
Okay, cool. Yeah, so I think only if, so I can add a condition like, if here I is equal to 0, in that case output I is equal to 0, so that I don't uh, end up doing this, di- yeah, dividing a number by 0. Dividing 0 by 0 itself
Okay,
would be, yeah, undefined. uh,
yeah. Okay.
yeah, you, do you want me to, like, test this?
Yeah, I'd love to see you just like verify this solution.
Okay, cool. Yeah, sure, I can write a test case. Let me just use the same test case I used earlier. So this would be 5, 6, and Yeah, let me run this now. Okay, this is just a warning, I think. Yeah, yeah, but ideally I should have ca- done this implicit casting
Mhm.
to integer.
Yeah.
But yeah, I think the output. Yeah, I think this should be the expected output. What do you think?
Yeah, that looks correct. And you also mentioned a couple of edge cases. Can you test that how your code handles those edge cases?
Okay, okay, cool. Um, yeah, one edge case would be like one of this is zero. In that case, I think it should be zero. Okay, okay. No, I think now I think that yeah, I missed this edge case wherein yeah, I think this solution is incorrect because uh
Hmm.
when this is yeah, like at least at the third position, the product should be 2 into 4 into 6, and that is not tested correctly. That is not,
Right. Yeah.
yeah, my implementation is not exactly
Yeah,
correct.
exactly.
Okay,
Hmm.
so what I can do is basically okay, so I can do this if error I is not equal to 0. Only then I create this product array. Only then I multiply it with the product. So in that case, yeah, so in that case, my value of product for this array would be 2 into 4 into 6. And let's see, for my output array, it would be product divided by, which is not exactly correct. So, okay. Yeah, I think
Yeah,
there
you.
needs to be, yeah, this needs to be handled differently. So,
Mhm.
okay. Yeah, I think this has to be like a separate case altogether. So, um, let me just use a better name for this. So I'm using a flag called zero, which would basically be set to one if there is a zero. So let's say now I can see that um, if the array has a zero, so in that case I can yeah the and I can just remove this case entirely from here, and then I can add this all and move this all under my else condition. And if I have a zero, in that case the out if the current integer is not zero, so in that case the output is actually zero. Otherwise, oh, I think I'm missing something else here now. This what I'm thinking is this solution would only handle the case when there is only one zero.
You only have to avoid dividing by the zero, right? That's like the only thing you have to avoid.
Yeah, that is true. But let's say no, that is not the only thing I have to avoid. Like, let's say my product itself is not correct, right? In this case, like don't multiply, if I multiply by zero, um,
Hmm.
no, what I'm thinking is, let's say eh, this is my case, like two, this is my input array 20006,
Yep. Hmm.
and in that case, my expected output should be uh, like zero,
Hmm.
0, 0, 0. But if it
Yep.
is
So you have
let's say
to keep
two
track of
zero
the
four, yeah, sorry,
yeah. So you have to keep track of like the non-zero product too, right?
yeah,
for the
Yeah,
product
but
of the
if there is only
non-zero
one zero, then I
elements.
need to keep track of the non-zero product. And if there are more than one zeros, then I can assume that the product would be
Mhm,
zero for all. Okay. So what I can do is I
mhm.
can count the number of zeros. Yeah, that would make more sense. Zeros is greater than one, then I just yeah. So if there is more than one zero, then I just return the output array, which has like zeros, only zeros.
Mhm.
And if if it is equal to one, in that case, I use this product. Um, so let me copy this for loop. And so in that case, if yeah, I think this is the only thing that was missing. Now I think this should work for the zeros, edge case at least.
Okay, yeah. Do you want to try a few different examples that have zeros in them?
Yeah, so I think for this one this works. Let me try with
Okay, yeah.
2006.
Mhm.
Yeah, this also works. Any other test case you want me to try?
Um, no, that looks good to me. Okay, great. Um, so I do have a brief follow-up question for you then. So this solution did use division. Could you modify your solution to not use division?
Sure, I can do that. So basically, for any given like position in the array, I need to find out the product of all the elements except that specific integer, right? So what I can do is
Mhm.
basically, which basically translates to product of all the integers before that integer and product of all the integers after that integer. So what I can do is basically I can maintain
Yes.
two arrays. One would be like a prefix array and the other would be a suffix array. So prefix meaning like product of all the numbers that come before that, and suffix meaning product of all the numbers that come after that. And like I can traverse through the array twice, once to compute the prefix, once to compute the suffix. And once I have that, I can traverse through the array again to multiply the prefix and the suffix, and that would be my answer.
Okay, so when you're traversing the first time to create that prefix and suffix arrays, are you multiplying together all of the elements that came before, or are you like reusing anything?
Yes, I will be reusing the value. So let's
Mhm.
say that at position 0, my prefix product of all the elements before that would be 1. And at any given index, it would be like the prefix for the previous integer multiplied by the previous integer.
Okay, sounds good. Yeah, let's give that a shot.
Let me clear this out. Yeah, so I've computed the prefix array. Let me compute the suffix array as well. This would be similar, just traversing in an opposite direction. So previously I went from 1 to n. Now I will start from n minus 2 to 0. I minus minus. So
For this part, how are you populating the very last element of the suffix if you're starting at n minus 2?
yes, so I have initialized the array with values of 1. So basically, for the last
Hmm.
element, the suffix, there is no element after that. So the product of suffix, I'm assuming it as 1, because if we
Okay,
multiply anything else with 1, that would be the same number.
right, okay. So it doesn't include the last element in the product.
Yes.
Okay.
Now I have my prefix and suffix arrays. Now I'm going to traverse through the entire array again and compute my output array. So here again, I'm creating an output array. Now our output I would just be prefix I into suffix I. Yeah, let me run this as well. Uh, Let me change the test case to the original one. Yes, I think this is the expected output. Do you want me to run some more test case?
Yeah, maybe we can check some of the edge cases that we had trouble with before.
Okay. Yeah, so this takes care of all the edge
Okay.
cases that we encountered earlier. Uh,
Do we check
Let
the
me
ones
try
with
with
multiple zeros?
negative. Yes, sorry, can you repeat?
Yeah. Sorry, did we check the one with multiple zeros?
Yeah, no, we did not. Yeah, let me check that as well.
Hmm.
Yeah, I was just running this for a negative number, and let me run
Great.
this
Yeah,
for
that looks
one negative, two zeros. Yeah.
okay. All right, perfect. Okay, so can you tell me the space and runtime complexity of this particular solution?
For this particular solution, the space complexity would be big O of n because we are using two auxiliary arrays of size n. N is like the size of this array, and the time complexity also is O of n. We're traversing through this
Okay.
array thrice, so we can assume like big O of n. We can, yeah.
Right, okay, yeah, because you're storing both the prefix and suffix arrays. So I'm curious to hear from you. Do you think you could reduce the space complexity down to O of 1?
Yeah, I think I can get rid of this prefix and suffix array and I can directly start with my output array here. So what I can
Hmm.
do is basically uh, uh, I can firstly I compute the prefix and I store it in the output array, and then I start traversing from the last element to the first, in the reverse direction. And
Hmm.
now instead of like like storing that value in a separate array, what I do is I can just maintain a separate one variable for that. So that would be like, let me just call it suffix prod or something, and then uh,
Hmm.
yeah, that would like store, keep computing, like I would keep multiplying it with whatever element I'm traversing, and I can multiply it with the current element. So let's say at the last position, which is O at n minus 1, there is the suffix is just 1. So I just multiply whatever my prefix output was till now with 1, and that is my
Hmm.
final output. And I also modify this suffix prod in variable to multiply by that integer. So yeah, so every position, first I multiply it by the suffix, and then I multiply the suffix by the current integer. So that would be the suffix for the element that comes just before that. Does that make sense?
Okay, yeah, gotcha. Yeah, can I see you implement that?
Yeah, sure. Let me, yeah, clear this. I can reuse some of this code. Um, I- suffix prod is equal to 1. So suffix prod.
Yeah, and to clarify, right, you're only using the actual output array as the extra space and
Correct.
just like a other constant, right?
Yes.
Okay, perfect.
And one extra variable is suffix prod, but yeah, that's
Yes.
about it.
Uh-huh. Yeah. Hmm.
Yeah, I think I'm done with my implementation.
Okay, perfect. Yeah, do you want to test it out?
Yeah, sure. Let me run this. Okay.
Okay.
Something isn't quite right here. Let me check.
Yeah, it should be all zeros, right?
Yeah, 0 0 plus 2 minus 4. Actually, okay, I start traversing from n minus 2. So basically, my suffix prod should already be,
The last element.
yeah, the last element.
Hmm.
Yeah, this, yeah, basically, I should have either changed it to n minus 1, or yeah, initialize it to n minus 1. Let me run this again. Yeah, this looks,
Okay, great.
yeah, let me run some of the other test cases.
Hmm.
This also, I think, is the expected answer. Um,
Yes. Hmm.
some more. Let me try with 1 0. Yeah, I think this covers all the test cases. Any other test case you
Okay,
think we should?
perfect.
Okay.
Um, no, that looks great. Okay, I think this is a great place for us to pause. Thank you so much, Daisy. That's really fantastic, and I love that we got through like basically three different iterations of this problem. So I'd love to hear from you first. What did you think of this interview? Like, what do you think went well, and what do you think you would have done differently?
I think what went well is basically, we discussed, like for all the solutions, we discussed a lot of different solutions, and for all the solutions we were able to figure out like what are the edge cases. We were able to call out, like, before running the code, so we were able to call out like what are the edge cases and how we can um, solve that. We didn't exactly like solve that completely, so like after running the code, uh, I figured out like what I missed. So that is, yeah, that can be what didn't go very well. But other than that, I think what went well is clarifying the question at the beginning, uh, and and also like the communication part, like discussing the solution with the interviewer. What do you think?
Yeah, I agree on a lot of those things. I really did like that you explained your overall algorithm before implementing. Um, and a lot of your implementations, you were able to get to the appropriate efficiency because you were thinking about how to reuse different like space or like how to basically try to be clever about how you're multiplying together like prefixes and suffixes and so on. Yeah, and I also really like that you considered edge cases like the integer overflow and division by zero, and you're able to correctly answer what the space and runtime complexity was for each of your solutions. As for things that might have helped a little bit, so I think a lot of the times when you were answering my questions about complexity, you gave me the correct answer, but it helps to also then explain, why that answer is correct. And also, as you're writing the code, it can also be helpful to just like explain the code as you're writing it, so that the interviewer can also follow along, and to make sure that you test all of your edge cases. Yeah, and then last thing, this is a really small thing, is just to try, if you can, to keep the code as readable as possible. I know it's always kind of difficult in an interview session. You're like under time pressure and so on. But yeah, sometimes like adding comments or separating things out into separate functions or even just maintaining the correct indents can be really helpful. Okay, what do you think?
Yeah, that was really helpful feedback. Angie, I agree with your feedback. Yeah, thanks a lot.
Okay, cool. Thank you so much for being here with us today, Daisy. This was really cool to see you implement all of these different types of solutions. And thanks everybody for watching. If you have an upcoming interview, good luck. Bye, everyone.